Hello and good morning friends, welcome to CEC-UGC live lecture. Dear friends, in this session today we are going to discuss on project management under operations research. As you all know that under this series, that is under operation research, we try to understand new topics. So today we are going to discuss about project management, and for this we have again with us in our studios Dr. Subhash Kakkar. As you all know,
hello.
He's an eminent academician as well as through his immense knowledge and experience, we try to learn new things, different things, and today also we are going to get a deep insight into this very topic. So first of all, I would like to welcome our guest, Dr. Kakkar. Dr. Kakkar, welcome to the EDUCET lecture, and I wholeheartedly thank you for delivering such a nice lectures in past also, in future also we would expect the same, but as far as today's lecture is concerned, I would like to get an insight through you.
Thank you. Welcome viewers. This lecture is part of series on operations research. We have covered a lot of topics. Yesterday we covered inventory management. Today we'll devote time to the project management. Project is something which is connected with activities. A lot of activities are to be completed so that the project is complete. It's not only one activity, but more than one activity, and then we call it a project. Now we have a lot of techniques which can be used to monitor the progress of a project. We have software available. We can use the software to handle big projects also. Now look at the times when we didn't have any technique available, we didn't have any software available, and how the projects were handled during those days. At that time, the project manager or the person who was handling the project used to make a list of all the activities on a piece of paper. Then one by one he used to complete those activities till all the activities are complete. When all the activities were complete, then we used to say the project is complete and we can have the inauguration, etc. for that particular project. But while carrying out this kind of job, means completing one by one activities, starting with the first activity, maybe he could complete first activity, and the second activity he used to see it that this particular activity cannot be completed unless some other activity is completed, because this particular activity follows some other activity, and at this stage when the only first activity is complete, there is a priority for some other activity. Then he used to make another list whereby he could see what is the sequence of activities, and that sequence, if followed, will complete the project. Then he used to prioritize all those activities. Again, while completing the project, he used to see that there are certain activities which are very critical in nature as far as the time is concerned and as far as the budget is concerned. So he used to put extra efforts on those kind of activities so that those activities should not get delayed. Now looking at the list, there are certain activities which are very time consuming. The project manager in the beginning, when he knows that there are so many activities which take a lot of time, he used to get worried. Unnecessary, he used to be tense. Because in the beginning, only those activities can be started or completed which are required in the beginning. But if we start thinking about the activities which are required at the later stage, and maybe those are critical and more time consuming, it is unnecessary worry to us. So there should be some method by which we can see that which activity can be completed today and which can be postponed at a later date. So while completing the projects, US Army came up with an idea. They were actually designing a ballistic missile so that they can launch those ballistic missiles from underneath the surface of ocean so that it should be deterrent to the enemy targets. This was a research and development project. It was not a straightforward project. So one activity and the options were two, whether successful or unsuccessful, whether success or failure. If the success is there, some other route is to be adopted. If failure is there, some other route is to be adopted. So US Army was in a fix how to handle this kind of project. So the engineers came up with an idea of network analysis, and this network analysis they called it PERT, Program Evaluation and Review Technique. At the same time, concurrently, the company DuPont and their engineers came up with another idea, though it was more or less the same idea, and they called it CPM, Critical Path Method. But prior to these two network analysis, the engineers started using a bar chart for making the schedule of a particular project. Horizontal bars showing the activity and its duration. And this bar chart idea was given by Gantt, and we call it Gantt chart also, and network analysis PERT and CPM. PERT, I have already given you the full form, Program Evaluation and Review Technique, which was given by US Army, and the CPM, Critical Path Method, was given by DuPont. We will devote more time on PERT and CPM. Gantt is very simple to prepare and visualize also, and we can make use of Gantt for monitoring projects. And PERT and CPM are two network techniques which are more useful than the Gantt chart. I have already told, during 1950s, US Navy developed PERT and DuPont developed CPM. US Navy wanted to launch the ballistic missiles. So they developed a PERT technique, which is a network technique. Full form of PERT is Program Evaluation and Review Technique, and this is a probabilistic model. What do I mean by probabilistic model? Activities and their timings are not exact. While starting the project manager makes a list of activities and puts duration to these activities, and these durations are only estimates, and these are probabilistic in nature. They may vary while carrying out the project. That's why this is called probabilistic model. And the other network technique, which is CPM, Critical Path Method, again it is a network technique, but it is deterministic model. Whatever timings we give to the activities, those timings are exact, because these are achieved by repeatedly carrying out the activities and then finally finding out the time of a particular activity. This time doesn't change during carrying out the project work. So this is called deterministic, and the PERT is probabilistic. How to make the network? I have an example, and three things are required for making a network. The first one is the job or the activity, list of activities which are to be completed. Predecessor, what is the preceding activity to each of these activities. We have to make a list of those activities also. Then finally we should know the duration of each activity. So in this particular slide, list of jobs to be completed, preceding activities are given, and the third column gives the duration of each activity. Now how to draw it? First we will make a node. We can draw this network in two ways. One is activity on node, and the other method is activity on arrow. Activity on node is called AON diagram, and activity on arrow is AOA diagram. And normally we show the activity on arrow. So we'll make the activity on arrow diagram. The first node is mentioned, and this is called the start point. Look at the slide. The first node is S. S stands for start. And from this particular node, since A and B do not have any preceding activity, so two activities can be started from this particular point. The first activity and the next activity, A, and then B can also be started from this start node. And 4 and 7 are nothing but the duration of these activities. A has a duration of 4 days and B has a duration of 7 days. So 4 and 7 are written. Two activities starting from the start point. These are shown like this. And next again we'll have a node. Node has been shown there. And from this again some activity will come out. Which activity will come out? We'll just see at the slide. So two nodes have been mentioned here because node shows the completion of the activity or activities which are terminating at this particular point. See, at node number 1, A activity is terminating, means A is getting completed, and node 2, activity B is getting completed. So 1 and 2 are mentioned as nodes. Now another activity which is coming out of node 1, because it is after activity A, so we'll see that C activity has a preceding activity A. So from A, C will come out, and C has been mentioned on this arrow, and the duration is 6 as mentioned in the chart. Now another activity which is coming out of the node 2 and which is after activity B. D activity preceding activity is B, so we will mention D on this particular arrow with an activity duration of 8 days. And after this, C and D are completed. We will not forget to put the node also. Okay, and then we see that there are two activities which are coming out from the activity B. The activity E is also after B, so we will mention activity E also on one of the arrows. E is mentioned with a duration of 8, and now we will mention that nodes also. That node number 3, where C and D activities are terminating, and from 3 we see that activity F has C and D 2 activities before it. So after C and D we will mention the activity F. Arrow has been drawn there and the activity F will be shown here. And at the bottom again one node is to be mentioned after E. So these two are mentioned. Node number 3 and 4, activity F is written on the upper arrow. Now after E we have an arrow, and this is G. G preceding activity is E, so E activity completed and G has been added over there on the arrow. Now we will mention the node also, and at this node all the activities are complete. We started with A, now from A to G all the activities are completed at this particular node, and this will be called the end node. So E stands for end. We started with S, now we are at the end point all the activities are completed, we have a relation which is mentioned in the preceding activities in the table mentioned in the slide. So this way we make the network. This is the network, we call it project network. We can name it PERT, we can name it CPM, but we'll name it CPM because only deterministic time estimates are given. There is no probability attached to these time estimates. So we have a exact duration of the project. Now the same PERT, we want to know the total duration of the project. How to find out? At each of the nodes, we'll make the milestones. These rectangles which are shown on each of the nodes are called milestones. And they have two cells, and we'll write something in these two cells. First cell, we'll write the early start time, and then in the second cell, we'll write the late start time. At the beginning, the node S, because no time has elapsed, so we'll write 0, 0. 0 has been mentioned. N milestone on the node 1, 4 has been written because we will reach the node 1 only after 4 days after completing activity A. So this is the way to complete the milestones. Now the second milestone on the node number 2, activity B is completed, it will get completed after 7 days. So 7 has been mentioned in the milestone for cell, and similarly we will complete all the milestones. Okay, now node number 3, there are two ways to come to the node number 3. One is via A and C, and the second path is via B and A. If we come via B and A, D will have a 7 plus 8, 15 days. If we come via A and C, will consume 10 days. And what is to be written? Whether 10 days or 15 days, because these are early start times, so we'll have to write the maximum timings in this particular cell. 6 plus 4 is 10, 8 plus 7 is 15. Out of 10 and 15, 15 is more than 10, we'll write 15 here. Similarly, in each milestone, we'll write the highest values at the early start times. Early start times are being written in the yellow cells. Okay, now we'll move on to some other event. Now event number 4, okay, we'll reach here after completing activity B and after completing E, and this can be completed in 7 plus 8, 15 days. That's why we have written 15 in the yellow cell, and these are early start times. Now we have one node left, and the milestone for that is to be filled up. So for reaching E, we can come via F and via G also. If we come via F, 15 plus 17, 32 days will be taken. If we come via G, 15 plus 4, 19 days will be taken. So we have to write the higher value. 32 is higher of the two, we'll write 32. So 32 has been mentioned. And the yellow cells are called early start timings. Now we have to fill up the values in the blue cells also. Start with the last point, which is the end point. In the end point, we will write the same figure which has been added in the early start time. That is 32 will be written there. So 32 has been written there. Now we will come back. From E, we will come back to node 3, we will come back to node 4, and we will write the timings. If we are coming at 3, we will subtract 17 from 32, so that will make it 15. If we come to node number 4, 32 minus 4 is 28. So we'll write 15 and 28. So this is the way to complete these milestones. 15 has been written in node number 3 and 28 has been written in node number 4. Now other nodes, node number 1 and number 2 will be completed. If we see node number 1, we can reach node number 1 via C. 15 minus 6 is 9, 9 has been written. And similarly, node number 2, we have written 7. Why we have written 7? We can come via D, we can come via E. 15 minus 8 is 7, 28 minus 8 is 20. Now, one thing is to be noted. In the blue cells, while we are coming back on the path, we have to write the minimum values. While going forward, we were writing the maximum values. While we are coming backward, we have to write the minimum values. That's why we have written the minimum values. And now we have to reach the start point. Now if we can come to the start point via activity A, and we can also come via activity B. Now if we come via activity B, the time will be 0. If we come via activity A, the time will be 5. Out of these two, we have to write the minimum value. 0 is the minimum value. We will write the 0 in node which is named as S. So 0 has been written. And these blue figures are called late start times. So yellow ones are called early start times, blue ones are called late start time. The milestones which have the same value as far as early start time is concerned or the late start time is concerned, and they lie on the critical path. What is the critical path? The path which takes the maximum time for completion. That is the critical path, and the critical path gives you the duration of the project also. In this particular project, the duration of the project is 32 days. Since 2 lies on the critical path. Why 2 is on the critical path? Because the both timings are same, 7 and 7. And next is node number 3, which also falls on the critical path because the milestone on 3 shows 15 and 15, same timings. The last one, ending point, ending event. So 32 and 32 are same, so this also lies on the critical path. So critical path is nothing but, now in this particular case, B, D and E, B, D and F. So these 3 activities lie on the critical path. The total is 7 plus 8 plus 17, which is equal to 32, which has already been shown. 32 days is the duration of the project. Activity B, activity D and activity F are the critical activities. What do I mean by critical activities? If we delay these activities, the total project will get delayed. This is the meaning of the critical activity, and the critical path is a path which takes the maximum time. This is the way to calculate the duration of a project, and this is the way to find out the critical path in a project. One has to learn this method so that any PERT can be made, any CPM can be made. So this is the milestone method of making the critical path and knowing the critical activities. So critical path has been shown in red color, and the critical path is B, D, F, and now we have to see the redundancy. Redundancy, while making the first table, when preceding activities are written, the project manager writes some extra information on the preceding activities which he should not be doing. So extra additional preceding activities are mentioned. So we have to find out which is redundant in the preceding activity column, predecessor column. So we have taken the same project and we have added certain redundant information in this particular table, and we have to find out redundancy, and this is done by redundancy test. How this test is performed, we are going to demonstrate. We'll make a table having first column and first row the list of activities, and in between there is a column which is called predecessor. First column has A, B, C, D, E, F and G. First row also has A, B, C, D, E, F and G. Now we'll pick up each activity and see the preceding activity. If preceding activity is there, we'll make a circle in that particular cell. So C has a activity, so under A we have put a circle. Okay, now D has B, so under B we have written a circle. Similarly, F, A, C, D. Here we are showing 3 activities which are coming out of activity F. So under A, under C and under D we'll put the circles. So this has been done. Now G also has B and E. Again B and E will put the circles. Now again we will see each activity. C has A. What activities after A? We will mention it on this particular table by a cross, if there is any. Now F, and we have mentioned cross over here because A, C and D are mentioned here, and similarly cross is mentioned here, B also, and G activity cross is mentioned under B. After completing this table, wherever circle and cross are separately marked, we will not touch those activities. But where circle and cross are together mentioned, that activity is the redundant activity. In activity F, A, C, D are mentioned, but under A there is a circle, there is a cross. This particular information is redundant. It is not required, so we will remove A as preceding activity to F. Similarly, activity G, the B activity is redundant. We will remove B from that. So that will remove the redundant activities, and this will complete the redundancy test. Now, if we don't remove the redundant activity and its information from the table, we will not be able to complete the network. We will not be able to make network unless this redundancy test has been put. So this is a must, and it should be carried out on the information which has been given before starting the project. This information is preceding activities, and of course duration also. After removing the redundancy, then we'll proceed and we'll make network. Now scheduling, project management scheduling with probabilistic activity times, and probabilistic activity times are available only in PERT, program evaluation and review technique. How to go about probabilistic timings. In the project, if any activity, a single activity is repeated a number of times and the timings follow beta distribution. Beta distribution is a distribution which is skewed towards positive values, skewed towards right hand side, and this particular beta distribution for activity timings will be used for making further calculations. In this particular distribution, we have 3 time estimates. For each activity, we will have 3 time estimates. One is the optimistic time, other is most likely time, and the third one is pessimistic time. Most likely time is a time when everything goes right, and that time is called most likely time. Optimistic time, the shortest time which the activity takes. That is called optimistic time. And pessimistic time, when all the things go wrong, whatever time we take to complete the project is called pessimistic time. And these are shown by TO, TM and TP. Mean activity time. Now we have to use the mean activity time. Most likely time we know, but we are not using most likely time. We have to calculate the mean activity time. We have to take into account the optimistic time and pessimistic time also. And the formula to be used is TO plus 4 times TM plus TP. We have to add all these and divide it by 6. That will be mean activity time. Now the probability distribution is there. When the distribution is there, we will have its variance also. Variance of activity duration. This can be calculated by taking a difference of pessimistic time and optimistic time. TP minus T0, will divide it by 6 and square of this is variance. And the square root of the variance is standard deviation, which is nothing but TP minus T0 divided by 6. So we are able to calculate the mean time, variance and standard deviation of one particular activity time. And the same thing is repeated on all the activity times. All the activity times are given in 3 time estimates. And based on these 3 time estimates, we will calculate the activity mean time. Now again I am repeating, in PERT, Program Evaluation Attribute Technique, we use probabilistic time estimates. And these probabilistic time estimates are based on beta distribution. While in CPM, critical path method, only single time estimate is used, which is deterministic in nature. Beta distribution, as I have already told, this is positively skewed. And formula for this is function of t, which is equal to k t minus a to the power c, b minus t to the power d. A, b are location parameters which will locate the beta distribution curve. C and D are shape parameters which will make a shape of the beta distribution. Whether it is flat, whether we have a peak, this will be given by C and D. If we have a smaller spread or a bigger spread, it will depend on the values of A and B. Beta distribution is a 4-parameter distribution. What are those 4 parameters? We have already studied A, B, C and D. Why choose beta distribution only? Beta distribution is bounded on both sides with non-negative intercepts, and it is clear that we cannot accept negative intercepts. We cannot have timings in negative numbers. It is a unimodal distribution. There is only one mode, and it permits flexibility of shapes by suitable choice of location and shape parameters, by suitable choice of the values of A, B, C and D. Easy approximation to mean and standard deviation or variance. So that is the reason why we use beta distribution. There are other distributions which can also be used, but beta distribution is the most appropriate distribution to be used. And these other distributions are uniform, triangular, exponential, normal, discrete and others. This is uniform distribution, one value all the time. So mean is A plus B by 2, variance is B minus A whole square divided by 12. Triangular shown here, A and B are 2 values, middle value is M. Mean is A plus M plus B divided by 3, variance is B minus A whole square plus B minus M whole square plus M minus A whole square divided by 36. Exponential is a function of M e raised to power minus mt, where mean is 1 by M, variance is 1 by M square. Normal distribution, all of the viewers must be knowing it. It is like this inverted bell-shaped curve with plus minus 1 sigma value around 68%, plus minus 2 95%, and plus minus 3 sigma 99.73%. So this is normal distribution. Each activity timings follow beta distribution. We shall be using beta distribution. If we calculate the timings of a particular path, like critical path, which is comprising of a number of activities, that particular time will follow normal distribution. Here in this case, normal distribution, mean is mu, variance is sigma square, and standard deviation is sigma. And likewise we can have discrete distribution. And it is only of academic interest because we shall be using only beta distribution in our all calculation. Basic PERT procedure. What is the procedure to be followed for making PERT? The network I have already explained. Compute mean, expected times and variance of all the jobs, all the activities. 3 time estimates are given. Based on that, we have to calculate the mean activity times. Conduct forward and backward pass on project network with expected times of all the activities. Using these mean times, we have to complete the backward and forward path. On the milestones, then we have to identify the critical path. Based on the milestones, we will have the critical path. Obtain variance of critical path by adding variance of all the activities lying on the critical path, and that will be the variance of the critical path. If we take the square root, this will be standard deviation. Now based on these informations, we can calculate the probability of completing the project at any time. Any time is given, mean time is given, we can calculate the probability of completing that project in that duration. So obtain the distribution of the project duration, make the probability statements about the project. First is, if somebody asks you chances of meeting the target date, we can give looking at the mean value. And one thing important to be noted here is chances of meeting the target date can be calculated as a probability figure. We know the date by which our network tells us it will be complete. We know the target date given by the senior management. Based on these two values, we will calculate the probability. Using the formula x minus mu divided by sigma is equal to z. Z coordinate we'll see it on the z tables on the standardized normal distribution and find out the probability, and that probability will be the probability of completing the project in that target date. Probability of exceeding a given ceiling date, again we can calculate that also, and we can also calculate the probability that the project duration is confined to an interval. Within these particular days we shall be able to complete the project, and we can calculate the probability of that using standardized normal distribution and z tables. Same example, now we have given 3 time estimates: TO, optimistic time, mean time, we are going to calculate based on most likely time TM and the pessimistic time TP. TO, TM, TP are given using the formula TO plus 4 times TM plus TP divided by 6, we will calculate the T expected, TE. So these have been calculated. 4, 7, 6, 8, 8, 17 and 4. These are the time estimates of the activities A to G. The range is also calculated. Range divided by 6 is the standard deviation. If we take the square of standard deviation, we will get the variance. So variance has been calculated also. So this is the way to proceed to get the probabilities of completing a project, and the same project is drawn here again, same network is drawn here again, and the critical path is BDF. This is the way how to calculate the probability of completing a project in a particular due date. Now, before starting the project, one can brainstorm how to reduce the cost of a project. We'll demonstrate it with some example. Brainstorming points can be points to reduce the project cost. Three points are being discussed. The first is negotiations. We should have very good negotiations with the vendors, suppliers and contractors so that we get the lowest rates for completing a particular activity. Then lower cost of money will also reduce the total cost of the project. That is the interest which we are going to pay to the banks or financial institutions, again should be minimum. Third one, use LST times. Keep project on time, save money. This particular statement tells us there are two times of starting a particular activity. One is early start time and the next is late start time. And use late start time so that you save on interest part, and that saving will be addition to negotiation saving and the lower cost of money. Unconventional method to reduce project cost is use LST times, keep project on time, save money. Two important issues in project management. One has to see, one is the activity timings and the cost of activity. Activity timings and the cost of activity are the important parameters in completing a project. And this is, we are discussing a particular project. In one of the companies, 8 machines were installed, activities are listed here, their durations and the funds required to complete a particular activity are also written. Of course, the preceding activities are also given. This is a list of activities for completing that particular project. It is not only on the paper, it was actually done on the site, this particular project. And these machines were tire manufacturing machines. And regarding these tire manufacturing machines, the activities are listed. And in this table, there are 5 columns. The first column is the activity number. Second column is description of that particular activity. Third column shows us the list of preceding activities. It gives us successor, predecessor, relation. And funds required are also written. And the last column gives us a activity duration in weeks. Some more activities, and here it shows that number of activities in this particular project were 47. And based on this information, a PERT diagram was made. And activity early start, late start times are also calculated like this. Early start time, early finish time, late start time, late finish times are calculated depending upon the duration of the project. So there were total 47 activities, and for 47 activities this information was written. And then a PERT was prepared, and this is the specimen of that particular project which was made, which was drawn manually. Here we have in all 38 nodes and 47 activities. Look at this chart. On each node we have a milestone. telling us the early start time and the late start time. And the nodes which have these timings equal, we have already mentioned that these nodes lie on the critical path. Now we will trace the critical path also with these red arrows. All those which have the same timings as far as early start time is concerned and the late start times will fall on this particular critical path. Yeah, we have completed the critical path and the duration of this critical path is 42 weeks. 42 weeks is again the duration of the project. Within these 42 weeks, all the activities will get completed, and this is the PERT plan. Now, we will calculate the cumulative cost curve also for this project, and it will be monitored. Monitoring project performance, saving cost, we shall be using cumulative cost curve. How to draw it? X-axis, the time is given, y-axis, the cost is given. Every month, how much cost is being incurred is written based on early start times, and the second is given on the late start times. EST and LST, and the blue ones and the red ones are giving you different information. One is for EST, other is for LST. And now we will have a curve joining these peak values. And we will retain the curves, we will retain the axis. On x-axis, we have shown the time, on y-axis, we have shown the cost. There are two curves, one is red, other is blue. The red one is based on early start time and the blue one is based on late start times. Okay, there is an area in between these two curves, and that particular area tells us the money being saved if we use late start times. We will save on interest part. In this particular project, how much was the saving? There are 44 weeks. Each month 4 weeks. We have written the EST cumulative cost and the LST cumulative cost, and the figures are written here. And the difference in every month is also written, starting from 403. If we see the difference, 403, 20, 47, 30, 15, 68, 22, 127, 50, 00. If we total them, this is the amount which will be saved if we use late start time. Total difference is 782,000 rupees, and total savings 782 into 18.18, 18% is the interest considered and divided by 12. So the total saving 11,73,000 just by using LST. When we are using LST, the project manager has to be very careful so that the things cannot delay, because he is using late start times. At the late start times, he hardly has a margin to delay the activity. So one has to be very careful, attentive while using late start times, but of course we have lot of saving potential if we use LST times. Okay, the buzzword is now use late start timings to save the cost. Now we will see the cost portion a step ahead now. There are costs, three costs which are connected with any project. One is the estimated cost, worth of completed jobs. While carrying out the project at any stage, we have to know estimated cost and so far how much jobs have been completed and what is the worth of those jobs which have been completed, and the actual expenditure which we have put in. These three cost estimates must be there. Of course, actual expenditure is not the estimate, but it's an actual figure, and the worth of completed jobs, again it is something which is real in nature. And this estimated cost is known as budgeted cost. Worth of completed jobs is called the earned value, and the actual expenditure is called the actual cost. At any stage, the project manager must know these three costs, and these should be available with him, because having a meeting with the top management, he is concerned about these three costs. Cumulative cost curve, S curve. For any project, we will make a cumulative cost curve. All these three costs are of cumulative nature. X-axis time, Y-axis cost, and this first curve, this is a cumulative cost curve, and which is budgeted cost schedule. Before starting a project, one can have a budget and how the requirement of funds will move as the project proceeds. This is another cost, actual cost. This shows that actual cost is more than the budgeted cost. What does it show? This shows that we are overrunning, but this is again a wrong statement. We are spending more, but we have to know how much worth of jobs we have completed if we have taken more money. Okay, now this third curve shows that value of work completed, which is earned value, which is more than the actual cost. It means we have spent less and we have completed the jobs worth more funds. So this one, blue one, is the value of work completed, rather earned value. So at any stage while carrying out the project, in a meeting somebody can be asked different questions, whether we are going ahead of schedule, we are going behind the schedule, is there any overrun or is there any underrun. So how to give an answer to all these questions, I am going to demonstrate it. We have to put a vertical line on the date when we are having a meeting. The project is partially completed. So this is today's date. Today we are having a meeting. In this today's date, we have a budgeted cost curve, which will be the final cost curve. We have two more cost curves which are ending only up to the today's date, because we have completed only up to today. Actual cost as well as the earned value cost. So these two costs will terminate at the today's date. Now, these two intercepts between budgeted cost and the actual cost, rather earned value, this much portion of the time gives us ahead of schedule. This is the ahead of schedule. This intercept gives us ahead of schedule. We are going ahead of schedule because we have completed jobs worth more of money required than it was budgeted. As compared to the budgeted cost and the jobs to be completed, we are going ahead of schedule by this much intercept time. And this intercept gives us underrun. We are consuming less funds in completing the activities. So this is called underrun. Okay. Here is the way how to tell the management that we are going ahead of schedule, or we are going behind schedule, or we are underrunning or overrunning. Now points worth noting here are: budget restrictions frequently limit the amount in any one period. Yes, resources are not unlimited in nature. Though we have activities which can be done in a particular time, but in certain cases we don't have the funds available to complete all those activities. Certain critical resources, men, materials, machinery, and so on may be available in limited amounts. Manpower is limited. Again, the material is also limited. We have to look into the availability of resources. We have to adjust the network accordingly. If budgetary or other resource constraints are such that even the late start cost schedule cannot be met, then finish date must be delayed and the activities must be rescheduled. That is the only way to take care of limited resources. Now, assumptions while making a network, whether we are using PERT, whether we are using CPM, there are certain assumptions which we have made. The first assumption is project can be subdivided into a set of predictable independent activities. This is the main assumption, but at the beginning we may not be able to predict all the activities and their interrelation. Precedence relationships of project activities can be represented by a non-cyclic network. Sometimes it becomes difficult because in a R&D project, when we are not able to succeed, we are to come back to our original position. This makes the network cyclic in nature. So we have to take certain corrections during that time. Activity timings may be estimated as a single point or as 3-point estimates. This is our assumptions. Whatever estimates we give or we make may not be correct. So this is again assumption. On this assumption, the other things are now moving.
Sir, we would like you to please conclude the lecture because we have no time left with us.
Okay.
So it would be better if you...
Yeah. Today we have learned so far the meaning of PERT, meaning of CPM, how to draw a network, how to calculate the critical path and the duration of the project. And somebody asks us the probability of completing a project in a certain time, we are able to give him the answer. Then based on our cumulative cost curve, in the meeting we can tell the members of the meeting that whether we are underrunning, whether we are overrunning, or we are going ahead of schedule or we are going behind schedule. All these questions can be answered if we have a proper network analysis and our homework completed before the meeting. And this is very important for the project manager to have a complete control of the project as far as the time is concerned, as far as the list of activities is concerned, and as far as the budget is concerned.
With this note, we would like to thank you, sir. Thank you so very much. I'm sorry I'm interrupting you, but because the time does not permit us to speak more. But as you have given so much to us through this lecture, I hope that in future also we would be able to learn more through you.
Okay.
Thank you, sir.